Hi folks, this is Nat, and this is going to be a video lesson on using probabilities to make predictions about what might happen in the future. Probabilities exist to help us understand how likely certain things are to happen, and one of the really good uses for this is it lets us kind of form expectations about what, we expect to happen in the future. When you think about making a prediction, it can be really simple. For example, if I think about, okay, the probability of winning the lottery is like 1 in 500 million, a prediction might be as simple as, well, Nat, you're really unlikely to win the lottery. I don't think it's going to happen. But the predictions we're going to be making today are actually going to be based around the idea of, well, if something's not going to happen every time, how many times might it happen? For example, let's say that I'm rolling a die. And I know the probability of rolling a 6 on the die is 1 in 6. One face of the die is a 6 out of 6 total faces, so I've got a 1 in 6 probability of rolling a 6. Now, the next time I roll the die, if I say, well, am I going to get a 6? Hopefully you're going to say, probably not. The odds are against it. The probability is not great that you're going to get a 6 on your next try. On the other hand, if I say to you, I'm going to roll this die 15 times, am I likely to get a 6? Hopefully at that point you start thinking, well, it's not likely to happen, but if you're going to roll it 15 times, yeah, you actually probably are going to get a 6, even though a 6 isn't super likely to come up any given time. Because even if something's not likely to happen, if I do it enough times, if I give it enough chances to happen, eventually anything's going to happen. If I play the lottery enough times, eventually I'm going to win the lottery. It might take longer than my life, but eventually you'd get there. So using my example of rolling my die multiple times, let's say, again, I am going to roll this die 15 times. With that information, I really should be able to predict the number of times I would expect to get a 6. And this is actually something that's pretty simple to do because you've done things like it a lot. When I say that the probability of rolling a 6 is 1/6, what that means is that I expect to roll a 6 once out of every 6 times. So it's the ratio of the number of 6s I'll get to the total rolls. Hopefully then it makes sense that I would expect that to be an equivalent ratio for the 15 times I roll it. In this case, I'm going to roll my die 15 total times, and the question I'm asking is how many 6s will I get out of those 15 total rolls? And what I've ended up setting up here is a proportion, which should look very familiar. And all the rules of working with proportions still apply. You're going to notice that my units line up. I've got 1/6 out of 6 total rolls as my probability, and then an unknown number of 6s out of 15 total rolls. Solving is also going to be exactly the same. We're going to cross multiply. 1 times 15 is 15, and that equals 6 times x, or 6x's. And I'm still going to divide both sides by 6 because that was what I multiplied my variable by. And I've got 15 divided by 6. The value of x then is going to be 2.5. And that's the answer to the question I wanted. How many times out of 15 would I expect to roll a 6? And probably my answer is going to be 2 or 3. If I need to be specific, I might round up to 3. And that's my prediction. Here's another quick example. Let's say that I've got this wheel, and I'm going to spin it. It's got a handful of red spaces, a handful of green spaces, and a yellow space. Let's say I'm thinking about the probability of... No, sorry, hold on. I want to know how many times would it take to spin, 15 green? To make a prediction about that question, the first thing I need to know is the probability of spinning green. And if I look, there's 4 green spaces out of a total of 8. So the probability of green is going to be 1/2. Half the spinner is green, so I've got a 1 in 2 chance of spinning a green. Every 2 times I spin, I would expect 1 green. And again, that is going to be proportional to multiple spins. If I spin 20 times, I'd expect half those to be green. If I spin 85 times, I'd expect half those to be green. In this case, I'm going to spin until I get 15 green. So if 1 out of every 2 times I spin a green, I would say that to get 15 greens, how many spins will that take? Again, as we look at this, let's think about our units. Units are super important in all proportions. 1 over here is the number of greens, and 2 is the total spins. So I want to make sure that to make a proportion that works, that my units match on the other side. So over here, 15, is it the number of greens? Well, how many times to spin 15 greens? Yeah, I want 15 greens, so that makes sense. I'm going to put it on the top. And how many times, how many total spins might be the other way that I phrase that, and I don't know. So this all works. Again, once I've got that all figured out, I'm going to go ahead and cross multiply. 2 times 15 is 30, and 1 times x is just x, and don't have to do anything in this scenario. X is going to be 30. So I would probably predict that it'll take 30 spins to get 15 greens. And that makes sense, because I expect half the time I'll get green. Now, in both these sorts of scenarios, it's important to recognize the difference between a prediction or a good prediction and what actually happens. If I think back to this one where I said, well, I'd expect two or three sixes if I rolled a dice 15 times. Maybe it'll be 2 or 3 sixes, but it might go crazy. If I roll a dice 15 times, at some point I'm going to get 15 sixes. That doesn't mean that my prediction was a bad one. It just means that things happened unusually. Some really unpredictable, low probability things happened. So your prediction doesn't necessarily line up with what ultimately happens, but it is the most likely thing to happen. Similarly on this one, it may not be 30 spins before I get 15 greens. I might get it before 30 spins, I might get it after 30 spins. But the reason we make this prediction is because it is the most likely thing to happen. So the value of doing this math is not that we're going to get it right every time, our predictions are always going to come true, but that our predictions are the best that they can possibly be, and I've given myself the best chance of being right. And here are 2 practice problems for you for this lesson. Both of them involve this wheel on the left. Be aware, I think it has 16 spaces, but double count that. All right, good luck.